So last week we did a lot of adding and subtracting decimals, amen? We focused on that the whole week. So this week we're moving on to multiplying decimals. And then what do you think is going to be after multiplying decimals? Dividing. Good guess. Dividing, okay? Which I love teaching that, so I'm really excited. But multiplying is really important as well, too, okay? Because we can look with that same example of money, because that's probably the most common place where you'll encounter adding, subtracting, multiplying, dividing decimals is with money. So if we're thinking of like something that costs $3.50, okay? Let's say it's like a ice cream sandwich or something, okay? And we wanted to buy enough for people in your family. So let's say there's 4 people in your family. We need to know how to multiply $3.50 by 4 people, right? So that's kind of what we're going to focus on today, and then we'll expand it throughout the week. So I'm pretty sure, unless something changes, I'm pretty sure we're just going to be doing multiplying this whole week, and then next week we'll move to dividing, okay? So there's that. Any questions on kind of what we're doing? No. Okay, so our objective is we're going to multiply a decimal fraction, which remember when we see that, okay, decimal fraction, our brain should go to, it's a fraction of a number, not like a fraction, but we're multiplying a decimal, right, by single-digit whole numbers, so that's numbers like 4, 7, 8. Would 11 be included in that? Yeah. No. Is 11 single digit? No, there's 2 digits there, right? So we're just doing numbers 9 and below, okay? And then relating to a written method, which is the standard algorithm, okay? So when we do like that question of 350 times 4, right? It's going to look like that, so we'll talk about that. And then we're going to use the area model and then our place value understanding in order to solve these problems. Yes, Donnie?
Wouldn't you say 10 below because 0 isn't technically counted as a digit?
It is a digit when it's 10, right? Because if it's not counted as a digit, hello? Anyway, you know what I mean. Take that 0 out, what is it?
1.
It's a 1. Wow. So, yes, 0 does count as a digit, okay? Unless it's before a number, right? So, all right. Cool. Let's see. I kind of want to bounce forward. We've done a lot of this stuff, so let's see. Okay. Cool. This is a subtraction problem. So let's look at it together. This will be like a warm-up, okay? So it says after school, Marcus ran 3.2 kilometers and Cindy ran 1.95 kilometers. Who ran farther? How much farther? So, looks like to me, okay, we're going to subtract these 2 numbers. So, looking at those, 3.2 and 1.95, I want you to think about which one's bigger, okay? Think about which one's bigger. Don't let it fool you. Don't let it fool you, okay? So, ready? Go. Which one's bigger?
Marcus.
Good. Marcus's is 3.2. And sorry, you don't have to write this. We're just going to do it as a class. It's like a warm-up, okay? Sorry, you do not have to write it. You can just look up here, okay? So we're going to subtract Cindy's amount from Marcus's, okay? So Cindy ran 1.95. Okay, does this look familiar?
Yes.
Yes. Okay, great. So remember, there's nothing here, but in order to help us out, we can put a 0 there if we need to, okay? So then we just start subtracting. We know how to do this, right? So can we take 5 away from 0? No. Can we take 9 away from 2? No. Okay. Can we take 1 away from 3? Yeah, which means we can borrow from our friend over there, right? So take 1 away from 3. How many 1s do I have left here? 2. Love it. Okay. That 1 moves over to the 10th place and explodes into 10. So we add 10 to our 2. What's 10 plus 2? 12. Okay, good. But I still need to borrow, so this is the part you guys miss. I'll wait until you're all focusing. Things are away. Cool. All right. Away. Or I'll take it. Awesome. All right. So, great. So we need to take 1 away from this guy, right? This is the part that we missed last week, so just please remember you're borrowing from each place value, okay? Anyway, take 1 away from 12. What do we get? 11. Good. And that gives us 10 here, right? That 1 we took away from the 10th place moves over to the hundreds, explodes into 10. 10 plus 0 is 10. Okay? All right, we good to subtract now? Okay, can we do rapid fire?
Yes.
Yeah? Okay, here we go, here we go. Look at it. Okay, 10 minus 5.
5.
11 minus 9.
2.
2 minus 1.
1.
1. So, Marcus ran further, right? We knew that before we solved the problem. Oops, my bad. Marcus, okay? How much further did he run? Go. Oh, nice. Raise your hand if you said kilometers after that. Nice. Give yourself a pat on the back. You are awesome. Because remember, Miss Witt likes you to label afterwards. So then it's 1.25 turkeys? No, kilometers, right? All right. Any questions on what we just did? Do you feel warmed up? Okay, great. Our brains are functioning now. We're getting ready to go. All right. Beautiful. Let's see. Okay. I am just going to do this one on my own, and then I will have you write some things. Are you ready? So right now, you shouldn't be writing anything. If you're going to be tempted, maybe close up your notebook. You shouldn't be drawing anything. Maybe close up your notebook. Well, if you're going to be tempted, I highly recommend closing your notebook. Just saying. Okay, all right, here we go. So this is going to prompt me through what it's going to look like to multiply numbers on a place value chart. Okay, so this is where our understanding of place value comes in handy, right? So it says draw 2/10 on your place value chart. So Miss Witt is going to do this. You guys can kind of just observe, okay? So did I do that right?
Yes.
Cool, okay? Maybe I should put it in the one above. I don't know why I put it in the second one. So 2/10 on my place value chart. Beautiful. Then it says make 3 copies of 2/10. Okay, I can do that. So that's 1 copy. Here's 2 copies. Here's 3 copies. Is this kind of familiar from last year where we did like big numbers in place value chart?
Yeah.
Cool. Okay. So great. So I now made 3 copies of that 2/10. Okay. So I, Miss Witt, have to look to see how many tenths I now have in all. So I see 1, 2, 3, 4, 5, 6 tenths. So I have 6 tenths, which means in standard form, okay, it looks like this, right? So, so then the algorithm, okay, the written method, or basically the multiplication sentence that I just did, was 2/10, right? Because that's standard form, 2/10. Everybody point at that and say 2/10. 2/10, good. I made how many copies of it?
3.
3, which means I multiplied it by 3. And what was my answer? Go.
0 and 6 tenths.
Good, 0 and 6 tenths, or you can just say 6 tenths, okay? But if there's like a 2 there, you should say 2 and 6 tenths. But yes, just 6 tenths is our answer, okay? Cool, okay? Question, Donnie?
Wouldn't you say 0.6 tenths?
Um,
Because the decimal is kind of like a point, like decimal point.
Decimal is also and, right? Remember that one lesson where I said it's blank and this? But remember, I want you to get away from saying 0.6 and just say 6 tenths. Like say it with the unit, okay? But for example, like how I said, you know, Marcus ran 3.2 kilometers, right? That's where it can kind of be excused, right? But when we're just talking about numbers, I want you to say 6 tenths times 3, or sorry, 2 tenths times 3 equals 6 tenths, okay? All right, can everybody look up here, please? I have people looking down, they're maybe getting sleepy, something like that, okay? All right, cool. Cool, any questions on what I just did?
No.
All right, if you could actually get your flimsy whiteboard out and your dry erase marker, that would be great. This is why it helps to have an organized desk, because then when I say, hey, get this out, you know exactly where it is. You reach in, grab it, boom, right? To be very fast. Thank you, Red Monkey Kings. Thank you, Crispy Bacon. Ooh, dang. Wiggly Wolves. Good. We're close. We're close. Good. All right. Cool. Yeah, we want you guys to move pretty fast. We don't want 3/10, right? We can read a multiplication sign as copies of, right? Everybody point to that multiplication sign and say copies of.
Copies of.
Oh, I don't see you guys pointing. Thank you, Leela. Thank you, Olivia. Thank you, Emma. Okay, thank you, Charlie. Ready? Point to it, everybody, and say copies of.
Copies of.
Good. So when we read a multiplication sentence, of course we can say 3 times 3/10, right? That's totally okay. But in order to help us understand what it looks like on a place value chart, we can say 3 copies of 3/10, right? Good. Or 4 copies of 3/10. Olivia, question?
Another way the short has is as groups.
Groups of. Good. Yeah, exactly. We could also do groups of, right? So 3 groups of 3/10, exactly. 4 groups of 3/10. Yes. Yes, definitely. Okay. We are going to do what this says on number 1, except it's going to be work with your group, okay? So I'm going to give you about, shouldn't take you longer than like 3 minutes. So I'm going to give you 3 minutes as a group to work together, okay? To solve both of these. Solve both of these. Find the answer to both, okay? If you need to draw like a line to split up your place value chart to solve both, go for it. Whatever you got to do, okay? Everybody understand?
Yes.
Okay, 3 minutes starting now. Go.
Okay, so we're gonna write group 3/10 and write the decimals. 1, 2, 3. Guys, can you help? Can you work together to explain? I know. Remember, some of these the one. Oh yeah, right. So you don't. It's like say this. I'm gonna actually hold your hands for all. But this should do. Technically, so
You got 30 more seconds. And St. Peter. So close, so close. Good job. Okay. If you guys have already solved it, talk about number 2. How were they different? Okay. You got 20 seconds. Go. All right, cool. Give me 5, 4, 3, 2, 1, 0. Okay, what's the problem?
She was kicking my foot while kicking my chair.
Okay. If she did, she probably didn't mean to. Okay? It's not intentional. If it's not physically hurting you, you're fine. Okay? It might be bugging you, but it's not hurting you. Okay? All right. Beautiful. So, how'd it go? Okay. So, my friends, I'm gonna put it up here on the board, and you're gonna double check your guys' work. But from looking around, looks like we're all pretty much on the same page. Actually, before I do that, class, when I snap my fingers, listen, make sure you're listening really carefully. When I snap my fingers, tell me as a group what you got for this one. 3 times 0.3, right? 3 times 3/10. Ready? Go. 9/10. 9/10. Love it. All right. When I snap my fingers, tell me what you got for this one.
1/10.
Okay. So a lot of you, I heard 12 something, which I'm assuming would be 12/10, okay? Which is technically correct. However, if we put it in actual standard form, move it over like we need to, it's 1 and what? 2/10. Okay? All right. Cool. Hold on. I know you guys already know, but we're going to just go ahead and do it really quick, okay? So we start with 3/10. Okay, does that look like 3/10?
Yeah.
Good. And then I've got to make 3 copies of it. So I start, remember when we're making copies, okay, we want to end up with 3. So we're not making 3 extra copies. We just want to have 3 total once we're done. So I'm making 3 copies of 3/10. So there's 1 copy already. Here's 2 copies. And here's 3 copies. Okay? So right there I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Which is my answer to my first one. Everybody with me so far? Cool. Great. All right. So then for the second one, okay, I start with 3/10. 1, 2, 3. Okay, and I need to make 4 copies of it. 4 copies. So there's 1 copy, 2 copies, 3 copies, 4 copies. Everybody with me so far?
Yes.
All right. Do you guys remember arrays? Kind of?
Yes.
So remember, I see 4 by 3, right? 4 by 3, which means I can multiply 4 and 3 together. Okay, 4 times 3, go. 12, okay, which means I have 12 little dots in my 10th place. If you weren't sure what I was talking about as far as arrays go, okay, you can just count them. It's fine. There's no shame in that, okay? But just when we get to like really big numbers in these place values, maybe don't want to like count them by hand, right? Because that could take a long time. But with a small number like this, we can just count it, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It also really helps to know your multiplication facts, right? Because if you knew that we started with 3 and we multiplied it by 4, then you can kind of guess right there that it's going to be 12, okay? But can I have 2 digits in a place value? No, okay? Which means that I've got to bundle a group of 10, okay? So, like that, okay? Those are donezo over here. They move over to the next place value, which means I have 1. They group together in 1, right? Move over to the next place value. So that means I have 1 in my 1's place, decimal, okay? Oop. And 2 left over in my 10th place, which gives me 1 and 2/10 as my answer. Okay, Kira, did you have a question? That's a good point. I'll bring that up there. So she said that their group did 4 3 times. However, technically that's right, but the question does say 4 copies of 3/10. So what you did was 3 copies of 4/10, which isn't what the problem was saying. So technically it's right. However, we want to solve it exactly how it says in the multiplication sentence, okay? All right, cool. So right now I'm going to give you another like 3 minutes, okay? I know it's tedious and annoying, but I do want you to put this example in your, notebook, okay? So I'm gonna give you like 3 minutes to kind of copy this down. You can make a really quick place value chart by just drawing a rectangle, putting some lines through it. You really only need the 1s and the 10s place, so you can just draw 2 columns. But I do want you to put both examples. I want you to write the multiplication sentences as well, okay? So basically copy everything that's circled in purple, Okay, and I'm going to give you like 3 minutes. Does that sound okay?
Yeah.
Okay, so 3 minutes isn't a ton of time, so make sure you're moving fast. Don't make it look perfect, just kind of get it on there. As long as you can read it, that's the important bit, okay? So 3 minutes, go ahead. Everything that's circled in purple. So really you only need the ones place and the tenths place, so if you want to just put 2, that's fine. Alright, about a minute and a half. If you're done, maybe go ahead and like close your notebook so I know you're good. That way I can kind of get a vibe. You guys okay?
Yep.
Okay. Not to move on, just in general, you okay? Okay, what do you need?
Medical attention ASAP.
Can't really give you sleep. But
And candy. I need no food. I need food. Yeah. I need food.
alright, back to quiet. I'm sorry I asked. Shh. Friends, back to quiet so people can focus. Shh. Back to quiet so people can focus. Alright, cool. I think we're pretty much good. So I am gonna move on, okay? Cool. Let's go, let's do well, we're gonna like just look at this one really quick and then I'm gonna have you do a more challenging one and I think we're gonna be good. I think you guys kinda get the gist a little bit, okay? This one says 2 copies of 4300s. Do you agree?
Yes.
Okay, cool. So then here it's gonna be the same thing, guys, right? Except now we have 2 digits in 2 different place values, right? But we're still making 2 copies of each, right? So notice when I flip to the next screen, okay, we started with 1 copy of 4300s. Do you see that?
Yep.
Okay, people who are looking down, you're just looking up here. You don't need to be erasing your board. You don't need to be messing with it at all. You're just looking up here. Okay, Maddie? Okay. So does everybody see how there's 4 tenths, 300ths? Yep. Is that what it says right over here? Yep. And then we made 2 copies of it. Do you see that? Okay, great. So starting from the right, okay, because in case we need a bundle or something, right, then I'm going to make sure I have, or I'm going to find out how much I have in each place value, okay? So, my friends, what is 3 plus 3? Go. 6. Good. What is 4 plus 4? Go. 8. Okay? Which means my final answer is 8600ths. Okay? So it's the same thing. Even though there's multiple digits, we still multiplied it by a single digit whole number. and got this. Okay? Alright, any questions about that?
No.
Okay, let me look forward to see. Yeah, we're gonna do this one, okay? It's a little challenging. It's a little challenging, but you can do it, okay? So on your, oh my gosh. You're fine. You're fine. Okay? On your whiteboard, I want you working with your group again, okay? You're gonna do 4 copies of 423 thousandths. Does everybody see that?
Yeah.
Everybody know the job?
Yeah.
Okay. I'm gonna give you about 4 minutes, okay? Ready, go.
Okay.
Go.
Right.
Okay, let's
Zero.
Okay.
Do what Charlotte said.
And then we're trying to and then 2 in the hundreds.
Luke, we're supposed to be wrong.
And then 3
Okay, then you. So do it again.
and then do 4 copies. Everything's gonna be times 4.
St. Francis. Oh, thank you, Oliver. St. Francis.
Pray for us!
Great. Henry had a good question. He said, do you want us to bundle if we need to, whatever? Yes. Okay, you're solving the whole thing. You're not just making the copies. You're going through and finding the final answer, which means you do have to bundle. You do have to bundle, okay? You've got about 2 minutes left, so keep going.
So in the hundreds we have 6, 5, 6, 7, 8, 9.
And then in the tens we have 16.
Okay, so just bundle.
So bundle 10.
It should be 1, 6, 9, 2. And then if you bundle 10, this is going to be 1.6, 9. And then 1.10. No, it's not. It's 2. Next problem is 4 times
You guys working together to get it done? Checking in on each other? Okay. You guys are all going together? Help each other out? Okay. Okay, about 30 more seconds, my friend.
So this is 12. You have to bundle again. 12 minus 10 and return it to 2.
Yes.
This will change
We didn't write the equation.
This will be 45. So the answer would be 1.692.
Ooh, I hit your A.
All right, cool. Give me 5, 4, 3, 2, 1, 0. Thank you, Charlie. Okay. Oh. 5th grade, I was just about to compliment you about how well we were doing with that, but as soon as I was about to say that, someone started talking. So, even if I'm quiet, you're quiet too. Okay? Okay, I'm being quiet. I understand. understand. But you know the difference between answering the question and then just making noise just to make noise. Okay? Hmm?
Say that we're gonna say nonsense.
Yeah. Okay. All right. Cool. Here we go. So, how did we do? Good. When I snap my fingers, class, tell me what you got. Ready? Go.
1,692,000.
Okay, that seemed pretty in unison, so it sounds like most people got that. So I will check to make sure you are right. Okay. Great. So we started with 423,000. Did everybody get that far?
Yeah. Woo.
Then we needed to make 4 copies of it, right? So there's 2 copies, 3 copies, 4 copies. Okay? Okay. Now we're talking nonsense. Okay? Okay. All right. Can I move on?
Yes, ma'am.
Great. Thank you. All right. So finding how many are in each place value is our next step, right? We need to start from the right side. Why? Raise your hand. Why do we need to start from the right side? Lily, go.
Because if you bundle, you can't bundle this way because that doesn't really make sense. So if you bundle, you have to bundle this way because
Good.
it like pushes all the numbers over.
Good. Yep. And it mirrors our adding decimals, right? Like when we add, if we have more than 9 in a place value, it bundles over, right? Carrying over that 1 or that 2 or whatever it is, right? Good. All right. So we had 3 thousandths to start with, and we multiplied it by 4, which means I ended up with 12 thousandths. Do you agree?
Yes,
Okay. Great. But Henry, what do I need to do? Can I have 12 there? No. What do I do?
Bundle.
Bundle. What do I bundle?
You bundle the 10, like the 1.
Good. I circle 10. Oop, those are donezo. And then, how many does it make in the hundredths place, Henry? 1. So I add 1 little guy to my hundredths place, okay? Which leaves me with 2 in my thousands. Okay, everybody good so far? Okay, great. So then in my hundredths, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, do I need to bundle anything there? No, we're good, right? All right, and then in my tenths, here we go. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Can I have 16 in my tenths place? No. Okay, everybody do me a favor really quick. You're looking up here. If you're messing around, I will take things away from you. Okay. So I can't, whoa, my bad. I can't have 16 in my tenths place, right? Notice how our answer, right, is 1.692, right? I mean, now that you guys are old enough, you've done enough bundling in your life, you know what it looks like. Oh, wait. Do I need to take it out of the way too? Flip it over or something so you're not distracted. Okay. All right. So you guys have done enough bundling in your lifetime to know that we circle a group of 10 and it moves over to the left 1 place value, right? Everybody knows that so far. Do you agree? Okay. Don't be silly and say no. Does everybody understand?
Yes.
Yes. Great. Okay. So, I give you permission, okay? Listen up. I give you permission to just look at that and know that the 1 moves over. Period. Okay? You don't, if that doesn't make sense to you, keep circling 10 and moving it over. Keep doing that, okay? There's no shame in doing that. However, in order to save you time and energy, since you know the why, okay? You guys know the why really well. Is that not a good friend? Is that what we should be doing right now? Okay. Okay, it's taking way too long for me to explain this, okay? So if, like, you guys know by now that I can look at that 1 and just pop it over to the next place value, because that 1 isn't a 1, it's like 10, right? If we're thinking 16, it's like 10, so we can move that 10 over to the 1s, okay? Everybody understand what I'm saying? Okay, let me get my writing utensil back. Hold on. Okay. So that 1 pops over to make it 1, 1, 6 tenths, okay? which gives me 1 and 692 thousandths. Okay, Charlie.
When you bundle, do you just like without doing the circles, do you just move one over?
Just move it over. Move like you can think of it as,
Do you erase the number that you moved over? Do you erase it? That would be not.
well, yeah, if I move the 1 over, should I keep that one there? No, that wouldn't make sense, right? So of course, yeah, or cross it out, whatever, doesn't matter. Okay, all right, any questions on that? I think you guys have pretty much got it. Let me see if there's anything else. Come on, hold on. I don't know what's going on there. Okay, weird. Oh, it's supposed to be there. All right. There is one last thing, and I am going to have you write it in your notebook in a second, okay? But right now, I just want you to look up here. If you could actually erase your whiteboards and put those away. I'll give you like 20 seconds to do that. Thank you, Jimena, for the 0. Thank you, Mika. Thank you, Brooks. Thank you, Leela. Crispy Bacon's just showing me a 0. I love it. I love it. They're ready to go. Shouldn't take that long, friends. We just put it in and take something else out. Very fast. Okay. Great. All right. So I'm going to do this really quick, and then I will have you kind of write it in your notebook after, and then have you practice with one, and then we'll be done. Okay? Sound good?
Yeah.
So right here, this little thing, okay, says the area model represents distributive property. Hold up. Area model? We can solve multiplying decimals with an area model? Holy cow. Let me show you what it looks like. Let me show you what it looks like, okay? So, since we, if you guys remember an area model, I'm going to flip to different screen really quick. Okay? Like if I had 2 times 12, okay? One of the numbers would go on one side, right? The other number would go on the other side. We also, and then we would solve what's inside, right? Remember, area is what's inside. I had you guys do this motion last year, right? So the area is what's on the inside, perimeters around. Is that familiar?
Yeah.
Okay, cool. So we would multiply them together because it's just like what it sounds like. An area model is finding the area of that figure, right? Of that model. To find the area, we do length times width, which is right here, right? Length times width. The order doesn't matter. You could say this is the length and this is the width. You could say this is the length, this is the width. Doesn't matter. Okay, bottom line, we're multiplying those two sides together. Okay, are we adding them? No, multiply. Okay, what is 2 times 12? Think about it. Go. 24. So the area of that would be 24. If we're finding the actual area, right, it would be 24 feet squared or whatever it would be, right? But bottom line, 24, okay? We also, sorry, I didn't mean to erase that part. Okay. We also could write that 12, okay? I'm not sure if we went over this last year as a class, but either way, we'll do it now, okay? So we could also write that 12 as 10 plus 2. Do you remember that?
Yeah.
Okay. So then we can solve, if that number's really big, we can solve it a little more easily by breaking it down, right? So 2 times 10, class, what does it go? 20. Good. What's 2 times 2? Ready, go. 4. Good. And then we add we add what's on the inside, we add it together, right? So what's 20 plus 4? Go. 24. Okay. Just a good review so far?
Yeah.
Okay. Great. So we can also do this with decimals. So I'm going to show you that right now, okay? So 4 could go on this side just because it's smaller, so we might as well put the smaller number on the smaller side, right? But it truly doesn't matter. It's just kind of smarter to put the smaller one on the smaller side. Do you agree?
Yeah.
All right. So I'm going to do what I just did with like that 10 plus 2, but I'm going to do it with that decimal, okay? So remember when we think about place value, okay, it's all It's all the same. If we're working before the decimal or after the decimal, it's all the same, okay? So here, I have to be clear about what unit I'm working with though, okay? I would pay attention to this, okay? This is really important. It will be on your homework, and we will be doing it kind of all week, okay? So I don't have to write 0 ones. It's not necessary. 0 is just nothing, right? So we can kind of skip over that. What place value is this 4 in? Tenths. Good. So I've got 4 tenths, okay, plus, what place value is that 2 in?
100.
Plus 200. Okay, and then I'm going to do plus what? 3,000. I'm going to pause. Does everybody see what I just did there?
Yeah.
Does anyone have questions?
No.
Okay. Beautiful, beautiful. All right, we're almost done. Thank you for your patience. One thing before I solve it, okay? Just want to show you. You will see it a bunch of different ways, okay? So you will see it in unit form like this, where there's a number and words, right? But you may also see it in decimal form, where it's like this. 0.4, right? Plus 0.02, right? Because that 2 is in the hundredths place. Okay? And then plus 0.003. Okay? Those are, the blue and the red are saying the same thing. Okay? Melina.
So on our homework, would it matter which way to put it?
Like this versus this? It does not matter. No. It might be easier to do this, to be honest. But yeah, it doesn't matter. Okay? So then we go through and do it exactly like we just did with that area model example before. Okay? So we do 4 times 4 tenths, right? What is 4 times 4? Go.
16.
Okay, 5th grade. Oof. 4 times 4, think about it. Go.
16.
16. And here's the kicker, okay? You need to be very clear about what unit, okay? So 16 tenths is what I would put there, okay? And I'll go back and show you the standard form in a second. So then 4 times 2 hundredths. What's 4 times 2? Go. 8. So it's 8 what? Hundredths, okay? So do you think you need to be labeling the unit when you do this?
Yes.
Yes, because if I just put 8 there, would that make sense to get 8 ones from 4 times 2 hundredths? No, okay? So you've got to be really careful about the unit when we're working with decimal fractions, right? The parts of a number. All right, and then 4 times 3 thousandths gives me what? Go. 12 what? Thousandths. Thank you. I want you to say the unit, okay? I want you to say the unit. It's all right, it's all right. Okay? Everybody with me so far? Okay. Then we can add all of this together, right? Which looks a little funky, right? So then this is maybe where standard form comes into play. All right? So 16 tenths, if I'm thinking about that in standard form, right? We're thinking of, like, this is a place value. Here's tenths, hundredths, right? There's, like, or I don't know why I put a 0 there, sorry. Oh no. Whatever. This is ones, okay? Oh my gosh, it's not working with me today. But anyway, if I had 16, guys, I don't know what's happening. Okay, hold on. Okay, 16 tenths. 16 tenths. Okay, thank you for your patience. Can I have 2 digits in the place value? No. So what did I tell you earlier that I just gave you permission to do, Melina? Make an excuse? No. What? Like with this? What can I do that I gave you permission to do, Olivia? Yes, just move the 1 over. Okay. So then it becomes 1 1 6 tenths, right? So 16 tenths is actually 1.6, right? Because I can't have 2 digits in a place value. Does everybody understand like how I got that?
Yes.
If you don't, now is the time to ask. Okay, so 1.6 is the standard form of that, okay? Okay, how are we doing?
Good.
Good, okay. Luke, can you show? Okay. All right. So then 800ths, I don't really need to be doing any like bundling there, okay? But to write that as standard form, it would be like that, right? 800ths. So this is also where maybe that place value chart might come in handy, okay? Because it has the decimal form written underneath. Everybody understand what I'm pointing at?
Yeah.
Okay, I'm losing you a little bit. Okay, I'll try and go faster. So then 12 thousandths, right? If I'm thinking of a place value chart, okay? Like this is thousandths, hundredths, tenths, decimal, ones, right? Okay? 12 thousandths, right? Guys, this is really important. If you're checking out right now, it's not the time. It's not the time, okay? 12 thousandths, remember I said you can move that one over, which means we're adding 1 to our hundredths, okay? So add 1 to our hundredths. We had 800ths, add 1, go.
9.
So it becomes 0.09. Just or 900ths or 0.09, okay? And that 2 stays in the thousands.
Yep.
Okay? So it's just like a place value chart. I know it's really confusing, but yeah, there's this 2 thousandths. Goodness gracious. I'm sorry, guys. It's just not happening today. But anyway, and then we would add all of those together, okay? So 1 6 tenths, okay? You have to be really careful with your place value, okay? And then 0.002, add it all together, okay? So 2 plus 0 plus 0 is 2, 9 plus 0 plus 0 is 9, 6 plus 0 plus 0 is 6, and then 1 plus 0 plus 0 is 1. So there we get our final answer that we got from like the last problem, right? Okay. Olivia.
If we end up getting 12 and 1,000, it won't be the same. It's not going to be the same.
Good question. No, only because, well, yes. Yes, but yes, okay, sorry. The answer is yes, not no. Yes, you can say that because that is 12 thousandths. The reason I said no in the beginning was because don't forget to add it to the hundredths. But yeah, so instead of adding it there, you could add it over here. That would be fine. Okay, so that's a really good point, Olivia. I'm glad you brought that up. Okay? All right, we're going to have you do one, and then we will take a break, okay? So if you could do, let's do this first one. Go ahead and just do it in your notebook, okay, in your notebook. So draw an area model, which is just a rectangle, right? And then do 6 times 1.21, right? Split it up into different place values. I'm going to give you like 3 minutes for this problem, okay? Of course, fine. Yeah, you can go on like the back. Yeah. Hey, let's go. Oh, let's go.
Wait, I wasn't on.
You saw most of it. Yes. I might put 1 up there, Henry, but yeah, that's fine. So draw a rectangle for your area model, and then remember to split it up. You need a pencil, but you need and extras in the back. You can use your hands on the top, see? You're not losing hands, messy hands. I know, so if it's not working and I give you time to work on a problem, then you find a way to get a different pencil and get started. cool. Here we go. 5, 4, 3, 2, 1. I see you, Lily. Hold on. Let me finish my countdown. Okay. Yes, Lily. Can you wait until I do it up here and that will answer your question? Cool. Okay. All right. So we can put 6 on this side. Did everybody get that far?
Yeah.
Okay, so right now you're checking your notebook, okay, to make sure you got it right. So I would put other things away that do not relate to math class. You're checking your notebook, okay? Away. Johnny, away. Okay, so checking your notebook to make sure you got it correct. Okay, you did it correctly each step. And go ahead and fix it if you didn't, okay? So, did everybody put 6 on this side?
Yeah.
Cool, all right. And then we go through each place value and just label the top, okay? Going through each place value, we label the top. So, I see I have a 1 right here. What place value is that 1 in? 1. Good. So I have 1, 1. Some of you just put 1, that's fine. For the whole numbers, that's fine. You can just put 1, but I'm kind of a consistency person. So if I'm doing unit form for all of, like for some of them, I'm going to do it for all of them, but that's just me, okay? So 1, 1 is how much I have. Plus, okay, what's the next place value? 2 tenths. Good. 2 tenths. Okay. Good. And what's the last one, friends? Go. 100. Okay. 100. Good. Okay. Donnie, I need you to wait until this is done, and then you may go. Okay. I just need to make sure that you got this right. Okay, because I would hate for you to miss it and have it wrong in your notes. Okay. All right. Then we can go through and just multiply. Okay. So, friends, what is 6 times 1, 1? 6. And we can just leave that at that. 6. Or you can put 6 ones, up to you. Okay. And then 6 times 2 tenths. Okay. 6 times 2, what does it go? 12 tenths. Okay. So 6 times 12, or sorry, 6 times 2 tenths is 12 tenths. Charlie?
Couldn't you start at that side?
You can. You probably should. Yeah, but I'm not too picky about it because we just go through anyway and like shift things around. But let's start there. We can start there because that will probably be easier anyway. Okay. All right. So Charlie said, can we start from the right side? And I think that actually would make more sense because if we are thinking of the standard algorithm, okay. This is how we would set it up. We would do 6 times 100th first anyway, okay? So Charlie, that's a great point. I'm glad you brought that up. All right, so let's start on this side then. So 6 times 100th would give me how many hundredths? 6 hundredths. Okay, cool. We already did this one, so it's 12 what? Tenths. It's okay. Be careful. Yeah, Dunny?
Wouldn't it be 2 tenths because you bundle it and move it over?
Have I gotten there yet, though? You're not wrong, but I'm not quite there yet. Okay, not quite there yet. So yes, we will do that, but we're not quite there yet. Okay. And then what is 6 times 1, 1? Friends, go. 6. Good. 6 ones, right? Good. So then I can go through, okay, and make sure that yes, that it's in its correct form. Okay. So can I have 12 tenths in a place value? No, right. So Danae, what do I do?
Bundle the 10 and fold it over.
Good. So in this case, it looks like a 1, right? Even though it's 10. Good. Ow. So it's 10 tenths. I bundle those and they become 1, 1. So what's 7 plus 1, friends? So what's,
7.
sorry, what's 6 plus 1?
7.
7. 7 ones. Good. Okay. So that one, that was with the 12 and the tenths places, bye-bye. Okay. So now my final number is 7 ones, decimal, 2 tenths, 6 hundredths. Okay. Donnie, you may go to the bathroom. Any questions?
Nope.
Donnie?
More of a comment, but just to answer what you said, 7 plus 1 equals 8.
All right. Cool. Does everybody understand the area model?
Yeah.
Yep.
Okay. Olivia?
Is it okay if you bundle and add it up?
Yes. Yeah. So I'm gonna have a moment of vulnerability really quick, and then we're done. Okay? Then we're done because we've been doing this for a long time. So I appreciate your your flexibility. Okay? So moment of vulnerability. Last year when I taught this, we did go left to right. So I'm actually very impressed and very grateful for Charlie for pointing out, like, hey, shouldn't we go right to left? Because honestly, guys, I'm realizing right now it's a lot easier than going from left to right. As you saw in the last example, right? It got a little confusing. So we should treat it like we're doing the standard algorithm, right? And go from right to left. So Charlie, like, give yourself a pat on the back. That was awesome, okay? So then, follow up to Olivia's question. We can, after we multiply everything and we're adding it up, we can add it, like it's listed. So 7 ones, which is like 7.00000, whatever. And then 12 tenths, okay, which really would be like 1 and 2 tenths, right? It would look like that. And then 6 hundredths, okay, which would look like that. So then Olivia's asking, is this kind of what you mean, Olivia? Like, so she made it 12 tenths like that, okay, like 1.2, instead of 12 in the tens place, right? And she added it up and still got the same answer because she would it would be bundled over at that point anyway. Except, hold up, you would get a different answer though. Because like, oh well, yeah. So when you do bundle it over, you have to, okay. Oh, I got tripped up. Okay. Another moment of vulnerability. I'm sorry. It would be 6 first. I was reading that. But it would be 6 first, right before we even do anything else. Then 1.20, then 0.06. Add it together. There we go. So then 6, 2, and then 6 plus 1 is that 1 that we carried over. So it would be 7.26. So, Olivia, to answer your question, yes, you can do that. Whatever is going to be easiest. Okay? All right, any questions about that?
No.
Okay, thank you for being patient with me. Thank you for being awesome. Go ahead and put your notebooks away.